What's up, everyone? It's Mr. Lang. For the last few classes, we've been solving systems algebraically. First, we learned the substitution method, and then we learned the elimination method. And you're probably wondering, well, why are we learning all these different ways to do the same exact problem? Well, the reason is sometimes it's easier to use elimination, and sometimes it's easier to use substitution. It depends on the problem. So in this video, I'm going to show you how to choose the best method. So really all you need is a sheet of paper and we're good to go. So let's get started. Alright, the first one here. We've got negative 6x plus 4y equals negative 18. And then we've got y is equal to 5x minus 8. So we've got a system of linear equations. These are both lines. And we could solve this by graphing, but that's, the way that takes the most time, I think, and is the least accurate. So let's solve this algebraically using either elimination or substitution. Now, my first thought is to do elimination because I like that method better. However, these equations are far away from being lined up. This is the x, the y equals, and the constant, and this is y equals mx plus b form. So this one's kind of a mess. So I'm going to choose, in this case, to use the substitution method. I think it's easier. I don't have to rearrange the formulas or anything. So I'm going to solve this by substitution because the y is already solved for, it's isolated already. So this y equals 5x minus 8. What I'm going to do is substitute 5x minus 8 into the first equation wherever I see a y, which is right here. So let's do this. We got negative 6x plus 4 times, instead of y, I'm going to put 5x minus 8. And this all equals negative 18. And now I just have to solve for x. First thing I got to do is distribute here, so this will be negative 6x plus 4 times 5x is going to be 20x. 4 times negative 8 is negative 32. And this all equals negative 18. I'm going to combine like terms on the left side. Negative 6x and 20x is 14x minus 32 is equal to negative 18. I'm going to add 32 to both sides. I get 14x is equal to negative 18 plus 32 is positive 14. And, well, this is easy. 14 divided by 14 gives me 1. So I got x equals 1. Using substitution, and I like substitution for one thing. It always makes the subbing in really easy because always plug it into the one that's already isolated. So this is y is equal to 5x minus 8, so this would be 5x minus 8, and now I'm going to sub in that 1. 5 times 1 minus 8. 5 times 1 is 5. 5 minus 8 is negative 3. So my solution is a 1, negative 3. And I just think in this case I didn't have to do any rearranging to use the elimination method. It was already isolated for y. So I think substitution was a clear choice here. Alright, let's do one more example. Alright, I've got negative 3x minus 2y equals negative 8. And 2x plus 2y equals 12. And so do I use elimination or substitution? And in this case, I think elimination is definitely the way to go because first of all, these are all lined up. That's a definite clue. The other reason is the negative 2i and positive 2i right here, they're going to eliminate each other when we add. So I'm going to choose elimination. And I can go right to the adding part. So negative 3x plus 2x gives me negative 1x. The y's eliminate each other, go to 0, and negative 8 plus 12 gives me 4. And then this is really easy to do. Divide by a negative 1, and I get x is equal to negative 4. And now I can sub this into either one of the two equations here. I'm going to choose the second one because it seems there's less negatives. It looks a little bit simpler. So this is 2x plus 2y equals 12. So this would be 2 times the negative 4 plus 2y equals 12. 2 times negative 4 is negative 8 plus 2y equals 12. Still solving for y here. I'm going to add 8 to both sides. I get 2y is equal to 12 plus 8 is 20. 2 times what gives me 20? That's got to be 10. So my answer here would be negative 4, comma 10. Definitely easier to do with elimination. Substitution, we would have had to solve one of these and isolate one of the variables, either the x or the y. Definitely more work than we need to do. Alright, so let's sum up what we've learned here. So in choosing the best method when you're given a choice, you'd want to use substitution method if either one of the variables is isolated, that makes it easy to use substitution, or if you just prefer this method, if you're really good at substitution, then do substitution. As long as you're getting the right answers, I don't really care if you're given the choice. And for elimination, normally you want to use it if the variables are lined up or are very close to being lined up, where you maybe only have to make one little adjustment. And the same thing goes with elimination. If you just like elimination and you're good at it, then use this method if you've given the choice. So let's get to the SIA questions. I've got 4 of these for you to do. You can solve them either by substitution or elimination, whichever one you think is going to be easier. I think you should practice both at least once. You don't want to do all of them by elimination or all of them by substitution, but other than that, it's up to you. So good luck, and thanks for listening.